Okay. So kind of get going here. So a couple things to mention before we get going. Um, so we've got that quiz two that's due to at the end of the day on Wednesday. So you've still got a little bit of time to get on and get that done. I'll change the settings today so that if you have completed it, you can start to see what your answers kind of were and kind of work through those problems as you're studying for that first exam, which is on Thursday. And I will post an announcement for what I said yesterday, which is it will be open from 9:30 a.m. till 3:30 p.m. on Thursday. Once you start, you'll have an hour and 15 minutes to complete it. I'll kind of go over this tomorrow's class as well, just kind of mentioning this so everyone's kind of clear on that and get an announcement up that uh, updates that time from what I originally had, I believe in the slides, right? From day one. So today is really just for review. We've covered all the material from modules one, two, three, and four. Any of the material we've covered is kind of fair game when it comes to that exam. So I'll be working today. If you have any questions, we can work through quiz one practice problems, quiz two practice problems, quiz one questions, or I've got some additional questions that I kind of, if I run out of questions from you, I'll kind of start working on that I think might be helpful when it comes to that first exam. So before we kind of get going, just I'll kind of go through whoever asks their question first. Are there any questions that people want to see from any of those materials?
For the second set of practice problems, I want to go over question 14.
Okay. You guys can see my screen right now, right? Not the
Yes.
that cam. Okay. So you said question 14.
Yeah.
Okay. So we've got a production function. You said quiz two, right?
Yes.
Okay. So we've got that the investment made into human capital must do what if we see that the real GDP of an economy decreases, right? Even keeping constant physical capital and labor. Okay. And then the second part is if instead we invest more into capital or physical capital than the amount of depreciation, what will happen to our real GDP? So if we're thinking about kind of that first part, um, so we've got this real GDP function, and it's our total factor productivity times K. Make sure I have these values corresponding to the question. Okay, so K to the 0.6 times L times H to the 0.3. Okay, so we know that if the real GDP decreases, right, what must be true about the investment we're making into human capital? Well, holding constant labor and capital, the only way this kind of would decrease, regarding human capital would be if we saw a decrease in human capital. Okay. Um, and I will kind of mention, I think on 14 and 15, I updated them this morning. The questions I changed from an earlier version, and the answer key to those two didn't get updated because they kind of moved in the order which the questions were. So if you had any issues with 14 or 15, make sure you're re-downloading that file or previewing it on Canvas, and it should have the corrected answer key now. So the second part of that question, so remember our physical capital is equal to the previous year's physical capital plus the investments we made minus whatever depreciation is. So here, if investments are greater than depreciation, we know that our physical capital would increase, which would then cause our real GDP to go up. Okay. Any questions on that idea or that question? So I'm going to add some things in here. because you did ask this question, something else that maybe I could tell you. So let's assume that the increase in employment is less than the increase that we see in unemployment. Okay. So I'll try to color code these to be like a separate example of here. Well, what's going to happen to my real GDP? Okay. Well, similarly to what we did for capital, my labor in the current year would be whatever the previous year was. And if you wanted to, you could rewrite this as LT and LT minus one. And then it's going to be plus my labor inflows, right? The number of new people becoming employed minus my labor outflows. I could think about this as the number of people being unemployed. Okay. So if my employment or my inflows are less than my outflows, what's going to happen to the amount of labor that we now have? It's going to actually decrease. Right? So if we're thinking about that real GDP function, if we see labor go down, what's that going to do to our real GDP? It's going to decrease it. So I could give you statements about investment and depreciation, tell you which one is greater, make statements about inflows and outflows to labor, which one is greater, and then you can come up with the corresponding changes in real GDP. Okay. Any questions on this? So quiz one, practice quiz one, 17 and 18. Let me make sure I didn't miss one in the chat before. Okay. So let's go to 17 and 18. Okay. So we've got some CPI questions, real and nominal value, and we want to know, okay. So when we're thinking about the real value of something, maybe I could put this in the context, wink, wink, of real income. Okay. So that's going to be whatever that nominal value is multiplied by the CPI in the old time period divided by the CPI in our new time period. Okay. So in this problem, I could think about this as, if I wanted to, just to kind of point this out, I could do the same thing with nominal versus real income if I change this problem, right? So real values, we could do income, we could do minimum wages. Well, eventually we did GDP. Okay. So what were we given? All right. So I was told that I've got 2025 and 2015. I was given the CPI in 2025, the newer time period was 185. The CPI in 2015 was what, 150? And we didn't know, we didn't know the nominal value or the nominal income, but we did know the real value was 1,240. Okay. So if I wanted to then find my nominal GDP, how would I do that? Well, it's one equation, one unknown. I would kind of take this, whatever this value is, if you want to do the intermediate steps off the screen, kind of use Excel to be my calculator. So 150 divided by 185 is approximately 0.81. So if I wanted to, I could kind of write this out. So then to find my nominal, I divide both sides by 0.81. So 1240 divided by 0.81, we get 1529.33 would be my nominal value there. Okay. Does that make sense on that one? Okay. Now, another thing I would think about is even if I didn't give you the values here, or if I did give you the values, what statement could we make about this economy? Well, anytime our real value, in this case, it was greater than our nominal value. Oh, sorry, no, it wasn't. Real was less than the nominal value that we calculated. So if that's the case, what must be happening to prices? Well, remember, nominal value, nominal income, nominal GDP doesn't control for prices. So what must be happening to prices if my nominal value is greater than my real value? Well, it must be that once we adjust for prices, right, that prices must have been increasing. And we said why. We could kind of write this equation out. You could remember this principle, but we said we could think about real value as kind of old prices times the current quantity. Nominal value is my new prices times kind of the new quantity. If I rearrange this equation a little bit, so I could kind of divide both sides by this here. What I would end up with is, well, this cancels, right? So I got zero. And then I have here, well, if I'm multiplying by the quantities, or sorry, dividing a quantity by itself, all I'm left with is new prices over my old prices. So anytime my real value is less than nominal value, this fraction is going to be greater than zero, right? Which would mean that, oh, sorry, not greater than zero. Someone should have called me out on that. Anything divided by itself is one, right? And so if this fraction is greater than one, what must be true? My new prices are greater than my old prices, or we have inflation. Okay. And that we can see that. Oh, let me see. Someone wants to know. So what does it have? So we're looking at, oh, that's because this should be divided by. Sorry, I'll get that updated here. So that was what? 529. Okay. So that would have been the equation if we were given nominal and calculating real. But in this problem, we were given the real value and we were being asked about what the nominal value is. Okay. Now, what else would tell us in this problem if we had inflation? Well, if I gave you the CPIs, right, this is a price index. So if I'm comparing the old to the new prices and prices are now higher, that price index is higher, that must have meant we had inflation. Okay. I could ask a similar type of question and say, okay, what if instead, and I didn't give you the CPI values, kind of working backwards, what if we had deflation? Right? So I'll do this work over here to make this maybe a little bit easier. So if I've got deflation, right? So I'll kind of rewrite this out so that we can kind of see what's happening. So I've got my real value is my nominal value times the CPI of my old time period divided by the CPI of my new time period. So if I have deflation, right? And I was asked instead, I didn't tell you the relationship between real and nominal value, but I asked you what it was. Well, if I have deflation, I know that my new prices are actually less than the old prices, in which case this fraction, if this number is less than this number, this fraction would be um, less than one, right? My old prices are, um, sorry, what do we want here?
I don't think we can see the whole paper.
Oh, well, that would help. Hold on. Let's do it. I'll come back to this, right? Because I rewrote this. So if we have deflation, right? The prices in the old time period are greater than the prices in the new time period. All right, so we're looking at a deflation, not an inflation example now. Okay. So if my old prices were actually higher, this fraction would be greater than 1, which would actually make my real value greater than my nominal value. So we can work in either direction. I could tell you that there's inflation or deflation. You could tell me about the relationship between real and nominal value, or I could tell you the relationship between nominal and real value, and you can tell me if there was inflation or deflation. Then I could also give you any of these three components and ask you for the one that we're missing. Okay. And then on 18, we have a similar kind of sort of concept. It's really just going through um, different different forms of this question, so we can kind of work through this here. So let's say instead, I've got, I was told the nominal wage was, so I've got my real minimum wage is equal to my nominal minimum wage, and then multiplied by CPI. So my older time period here was 2025. My new time period was 2026. So I was given the CPI in 2026, so that was 210. Right? I was told that the nominal minimum wage in both time periods was $9. Right? If that real minimum wage in 2026 was what? What is so 18. So if the real minimum wage was greater in 2026, then the CPI must have been what? So if I know that the real minimum wage is greater in the new time period, but that the nominal wage in both time periods didn't change, the only way that is true is if this fraction, right, is greater than 1, in which case I know that this numerator must be greater than the denominator, or that CPI in 2025 must be greater than 210. Okay. Oh, hold on. Did I miss something up here? So that should be greater than 210, right? Yeah, that's the only way that would kind of hold. Okay.
So in that case, there would have been deflation.
Exactly. Yeah. And then um, the second part of that question is kind of a similar sort of idea. We were just given we were given the CPI in the old time period. We also had kind of nominal wages actually going up. So if I have problems like this, so I'll rewrite this out for question, second part of question 18. So if I've got the real minimum wage in, let me make sure I'm not missing anything here. Oops. Okay. So the real minimum wage in the newer time period is equal to the nominal minimum wage in that time period, multiplied by the CPI in the older time period, divided by the CPI in the newer time period. So in this question, um, we are looking for what's true about the real minimum wage in 2025. So, if we see prices increase, so kind of the first part of the question is just additional information, because I'm not asking you about the relationship of the CPIs. I'm just telling you that prices increase. Okay. So if prices increase, that means the CPI of the newer time period is higher. Okay. If that's the case, if this denominator is higher, this fraction is going to be, I'm dividing by a larger value, it's going to go down. That would cause my real minimum wage to decrease. Okay. However, if at the same time I see that the nominal wage, I was told the nominal wage actually increases, So that's going to increase the real minimum wage in 2026, in which case, if I have things that are going in opposite directions, I actually can't make a statement about what's going to happen to that real minimum wage. So, any other questions you guys want to see? Otherwise, I've got a set of questions we can work through. Nobody? Okay. So I'll probably work through some older stuff here. And then I've got kind of a set of questions if nobody asks anything that kind of covers the newer material tomorrow. Um, but let's think about an example where I've got unemployment and I have something with discouraged workers. So this might not pop up as much in kind of the practice problems in the quiz, but if I'm thinking about my unemployment rate, okay, it should be the number of unemployed individuals divided by my labor force, which is going to be the number of employed individuals plus the number of unemployed individuals. Okay. So if that's our kind of starting unemployment rate, and I could come up with some values here. So let's say I gave you some values and I had, I don't know, 100, and just to kind of keep the math easy here, initially I had 900 employed and then those same 100 unemployed. If I've got discouraged workers, right? So maybe let's say that of these unemployed individuals, 50 of them become discouraged, right? And they stop searching for a job. Well, if they're no longer searching for a job, they're no longer considered unemployed. So these discouraged workers, let's say that there's 50 of them. Okay. So I could go through the math if I gave you these numbers, right? The new unemployment rate would be um, what, 100. I'm losing those discouraged workers. So I'm left with 50. And then my number of unemployed, well, now I'm losing those discouraged workers. So this would become what? Minus 50, so 950. So if I make this calculation, initially, I had an unemployment rate of 10%. Now, I'm calculating the rate here. I was kind of using this, kind of left something out. We can always calculate the rate, but if we want it as a percentage, we would need to multiply it by 100. So if I find this ratio, it's 0.1. I multiply by 100 to get 10%. Same kind of idea down here. If I want to turn this into a percentage, I would multiply this by 100. So if I do what? 50 over 950, my new unemployment rate is 5.3%. Okay. And the reason why it decreases is because those discouraged workers, it's always going to be a larger percent decrease in my numerator than it's going to be in my denominator. So if the change in the numerator is less than the reduction in the change in the denominator, I'm always going to have an unemployment rate that is lower when I have discouraged workers. But if I gave you the actual values, this would be kind of the method that you would go through to solve that. Any questions on that before we keep moving here? So a similar idea would be something like the following. Okay. So let's say I'm thinking about my employment population ratio, which is the number of employed individuals over that CNIP, or if it's easier to think about, that's kind of my non-civilian population, right? The number of people that I have in my economy. We also had the labor force participation rate, which was the number of people in our labor force, right, divided by that CNIP or divided by the population. Okay. So let's think about an example where if I see that the number of people who are taking part-time work when what they would actually desire is full-time work, right? How is that going to change these ratios? Okay. Well, if they are taking part-time work instead of full-time, right? The number of people that are employed and the number of people that are in my labor force actually hasn't changed, right? So when we have these underemployed individuals, it's not going to change my employment population ratio or my labor force population ratio. In fact, the only thing that these underemployed individuals are going to change, right, is even if I looked at my unemployment rate, once again, that's the number of unemployed divided by the number of employed plus the number of unemployed. Well, these people are still employed, right? So there's going to be no change in my unemployment rate either. The only thing that's going to change when I have this situation is that when I'm calculating my underemployment rate, remember that was the number of people who are underemployed divided by kind of that labor force. But here in that numerator, right, these people who are underemployed were still here. So my denominator doesn't change, but the number of people who are underemployed is now going to be the number of people who are unemployed plus that number of people who are taking part-time work when they wanted full-time work. So that underemployment rate is now going to be higher if we have anybody who is taking part-time work that wants full-time work. In which case, if the numerator is always greater for the underemployment rate, one thing that we can say is that the underemployment rate will always be greater than the unemployment rate. Okay. Any questions on this? Let's think about another example we could see with unemployment that might come up, right? So if I've got those same equations, right? So I've got my unemployment rate was the number of unemployed divided by my labor force. My employment population ratio was the number of people who were employed over my population. And then my labor force participation rate was the number of people in my labor force divided by my population. Okay. So what if I've got people who are retiring? Okay. And let's assume all these people who are retiring, right? The fact that they're retiring, they previously would have been employed. Right? So what's going to happen to each one of these ratios? Well, the national civilian population, or sorry, civilian non-institutionalized population, that's just anyone who could be working over the age of 16, right? Well, these people who are retiring still could be working. So that population actually isn't going to change, right? However, those people are dropping out of my labor force, in which case my labor force participation ratio is going to decrease. If they all were previously employed, it's also going to reduce the number of the number of employed individuals, in which case my employment population ratio would decrease. However, if they were all employed, right, I could kind of rewrite this. This might help to see. So we said the unemployment rate is the number of unemployed divided by the number of employed plus the number of unemployed. Well, these people retiring doesn't change these values. What did it change? It decreased the number of people who are employed, which decreases my denominator. So people retiring, as long as there's no other changes, would actually increase my unemployment rate. And if they were, the same kind of thing would apply if I asked you about the underemployment rate here, right? The underemployment rate wouldn't change, but those people who are retiring are leaving kind of that labor force. Any questions on that idea? I'm not missing anything in the chat. Okay. Another question that I think would be valuable to go through and you could be asked is, let's say I gave you the current inflation rate. And so let's say I told you inflation is currently 7%. Okay. I then give you the CPI. Think what I want here. So I'll give you the CPI in 2025. So, oops, sorry, the CPI talking and writing in 2025, and let's say this is 200. Okay. If I asked you what is the CPI in 2024, how could you figure this out? Okay. So I think we worked through some examples similar with growth rates, and we said, a lot of stuff we do with inflation and growth rates is going to be very similar because inflation is measuring the change in prices, growth rate is measuring the changes in output. So really, it's just differences in notation. Okay. So here, the way that we would calculate inflation is going to be the CPI of my newer time period minus the CPI of my older time period divided by whatever CPI kind of started out as. Okay. So that would be my CPI in 2024. So here, one thing I left out is this is a rate. If I wanted inflation as a percentage, I would have to multiply this by 100. Okay. So I was given the inflation rate as a percentage, so that's what I'm going to have to do, right? I'm calculating inflation, making sure I'm representing it as a percent. So I know that the new CPI was 200. I want to solve for the old one. Well, it shows up twice. This is a little bit tricky, right? Now we'll work through some math, and if you can remember the final equation, you can kind of skip some of this. But if I rearrange this, right, and it probably helps, I'll do this in the general form. It's probably easier to plug your numbers in first, but let's just kind of do some math here. So the first thing I'm going to do is I'm going to divide both of these sides by 100, right? So I've got now inflation divided by 100, right? I'm then going to multiply both sides by that older CPI. So that's going to cancel. And I'm using numbers here for the time periods. If it helps, you can think about this as old, and this is my newer time period. Okay. I then have the CPI of um, 2024. So I'm going to add that to both sides. This cancels. And what I'm now left with, the only thing I'm left with on that right side of the equation is my CPI in that newer time period. Okay. So that was just rearranging the equation a little bit. And the reason why that's helpful is because now that I have all of CPI on one side, well, notice in both of these, there's a common, I'm multiplying them by a common amount because I could almost think about this as 1 times that CPI in 2024. So I could pull that out to the front. And what I'd be left with is my inflation rate I was given as a percentage divided by 100. Once I pull this out, all I'm left with is that value of 1. This should be equal to my CPI in 2025. Now, once again, it might be easier instead of, I have this form of the equation, plug my numbers in first. And so then I'm dealing with, 7 here, and I'd be dealing with, what did I say? 200 over here. Okay. So once I have this form of the equation, now it's just a matter of plugging in my values. So I know that this was 200. I know that my inflation rate was 7%. I'm looking for that CPI in 2024. I would then, so this is might make it easier. What is this? This is what? 1.07. I'll divide both sides by that value, and that's going to now give me that CPI because this cancels in my older time period. So I don't know if I do this math, what I get 200 divided by 1.07. Oh, yeah. So that's what 186.9. Okay. Now, one way you could check yourself um, is if I calculate this value, if inflation was positive, I know that what was happening to prices. Well, if inflation was positive, that meant my prices must have been increasing, right? So if my inflation is positive, the only way that's true is if my new prices are greater than my old prices, or my new CPI is greater than my old CPI. Excuse me. So sure enough here, my new CPI was 200. The old CPI calculated was less than that, right? So that would be kind of the evidence that, right, yes, I do have a positive amount of inflation that kind of matches up with the initial numbers I was given. Okay. So if I wanted to not do this math every single time, I could rewrite the equation out to be this way. If I'm looking for the CPI of the older time period, that's always going to be the CPI of the new time period divided by 1 plus whatever inflation is, but in decimal form. So if I'm given the inflation rate as a percentage, to convert that into decimal form, we simply divide it by 100. Okay. Now I could also rewrite this equation that if instead of given the new CPI, I was given the old CPI, my new CPI would be equal to whatever my old CPI was times 1 plus that inflation rate in decimal form. Okay. So another way to check yourself to make sure you're not um, making the decimal form mistake. So I think this is the screen you should be able to see. Yeah, so you can see my Excel file. So when I was calculating this, I took that CPI and divided by 1 plus that decimal form So let's say I had, just to kind of rewrite this here to make this point, and actually do a placeholder here. I want to make sure that we can see this easier. There we go. So I was dividing this by 1 plus my inflation rate, which when I was using decimal form was 0.07. Okay. So going from, that, oh, what did I, sorry, left off my parentheses here. Okay. So, my one CPI was 200, my other one's 186. These CPIs shouldn't be wildly different, right? In fact, if we had an inflation rate even of 100%, would make that what, one? We're still saying only that's a doubling, right? The CPI is the difference is only 100. So if I don't use this decimal form and I accidentally include the percent form, I'm going to get something that varies by more than 100 in terms of comparing those CPIs. So if you ever see a difference in your CPI values that is more than 100, you probably know, right? 200 minus 25, you've got 175 as the difference. You probably made an error, right? And that you should have been using the decimal form. So just kind of adding that in as an additional check when you're working on those types of problems. Okay. Any questions on that idea before we keep moving here? Okay. Where are we at in time? All right, we still got 30 minutes. So what do I want to work through now? So I wanted to kind of clarify based off some of the questions I was getting over quiz one. Um, kind of make just I don't know, reiterate this point. If I have disinflation, okay. So if I have disinflation, it's going to look something like this, right? So if I've got 2010, 2011, and 2012. Okay. In order to have disinflation, it implies that we have inflation, right? So, sorry, I had to take a drink there. So let's say I have an inflation of 2.5 here, and let's say I've got an inflation rate of 4.2 over here. Okay. I don't know what inflation was in 2011. Right? So I can think about here. These are my inflation rates. If I told you that the economy experienced disinflation in 2012, what would have to be true? Sorry, I'll do it this way. Let's say they experienced disinflation in 2012, but they did not experience disinflation in 2011. Well, if that's the case, if I didn't experience disinflation in 2011, a statement I could make, right? If I was giving you like which of the following is must be true. Well, if I asked you what that inflation rate is in 2011, if I'm not experiencing disinflation, I would still have, right, some level of inflation because I know that in 2012 there was disinflation. So comparing 2012 to 2011, I know that they both have inflation and that my new inflation rate is just lower. So I know that I've got inflation here, but if I don't have disinflation, then I know that the inflation rate in 2011 must be greater than the inflation rate in 2010. That's the only way I don't have disinflation. And so I know that it's going to be greater than 2.5. Okay. Now, if I know instead there's disinflation in 2012, what I know for sure is that the inflation rate I see in 2012 must be less than the inflation rate I had in the previous time period of 2011. So I could also say with certainty that the inflation rate in 2012, right, which was 4.2, must be less than the inflation rate in 2011. So I know that that must also be greater than 4.2. Now, here we have an example where those kind of overlap, right? Um, that might not necessarily be the case. So what if I had, oh, so I have disinflate. Actually, sorry, the way that I have these numbers set up, that would always be the case. I would have to have like something like, I don't know, 6.7 here and 1.3 here. I could kind of do the same setup, in which case, like those signs might not always be going the same way, right? Because if it's greater than 2.5, it has to be sorry, if it's greater than 4.2, it has to be greater than 2.5. If this number was larger than the other, those greater than less than signs might not be the exact same thing. Okay, so just kind of wanted to make that point just because the numbers work out this way in this example. And it probably would help if I wrote this out in the same order. So just so you can see that, if I flip this around, all I'm really saying is so then we can kind of see, right? This would have to be greater than 2.5. This has to be greater than 4.2. These signs don't always have to match up. It kind of depends on like the relative values I'm giving you in these two time periods. Okay. So just because we have disinflation doesn't mean we have deflation, right? All of these values are positive, right? To have disinflation, we still need all of these values to be positive, in which case, what is another statement I can make, right? Well, not only do I know that the 2011 kind of must be less, let's say I didn't tell you what inflation was in 4.2. I'm sorry, I didn't know the inflation in 2012, so I didn't know 4.2. But let's say I gave you the inflation rate in 2011 was 3.5. Well, you know that in 2012, if you had disinflation, then that inflation rate in 2012 must be less than what it was before, so less than 3.5. But you also know that if you experience disinflation, inherently that means you have inflation, in which case you also know this is going to be greater than zero, right? You don't have deflation there. So that would just be kind of using a similar concept, but I give you this, I don't give you that. You could answer similar questions. Okay. Any questions on that before we keep moving here? Are you okay with that? Okay. Um, One thing I haven't done yet, and we'll kind of do it now, and it gives us a little bit of review of newer material, is I've got up, it was up here. Let me refresh this. So I've got that June 30th daily quiz. So this is some newer stuff. We'll kind of work through this. This might help as you're studying for quiz number 2. And it's all things that we talked about from module 4. Okay. Let me make sure. So we've got that June 30th daily quiz. You should be able to access it from the homepage on Canvas. It's open for 10 minutes, so we'll kind of work through these questions together. So the first one kind of relates to things that we actually talked about back on Friday's class period. So if we're thinking about investments made into capital and labor, which of the following is going to be true, or in this case, which of the following is not going to be true? Okay. So if we're thinking about investments into capital, right? And we also have this idea of total factor productivity changing. Okay. So let me go here, stop share. So if I have this per worker production function, we had some amount of investment in the capital, and that was leading to a certain amount of output, or we could think about this as a certain level of real GDP, right? Right, because real GDP should be measuring our output. So we said one thing that's going to be true about this curve is that when I invest more in the capital, right, that same $100 invested, and I'll try to keep these visually the same, right? As I increase the amount that I'm investing in the capital, what's happening to the change in capital? Well, here I can see I go from a relatively large to a relatively small change. So as I invest more into capital, the resulting change in my real GDP or the change in my output is going down, right? And the exact same thing is going to be true if we make investments instead of into capital, we make investments into labor. Okay? So if we're looking for which of the following is not true, oops, there we go. As we invest more into capital, there is an increase, or sorry, the increase in real GDP is decreasing. So that one's going to be true. If we invest more into labor, the increase in real GDP is also decreasing. All right, so both of those will be true, and we're looking for which of the following is not true. So the second, we can kind of look here. What if total factor productivity increases? Okay. So if total factor productivity instead increases, we can think about this relationship between capital and labor investment. So we've got the same kind of setup. So I could think about this is my investments into capital. Here's my real GDP or my output. We've got a production function that looks something like this. We said if I see an increase in total factor productivity, this is going to be kind of shift up our production function, our per worker production function. So what we know, right, is that the same amount of investment into capital is now going to produce a higher level of output after this total factor productivity increase. So if I'm looking at kind of that quiz, I think there's an option that says as total factor productivity increases, the same amount of investment into capital will result in a higher real GDP. Okay. So that's going to be true as well. We're only left with one other option. Okay. Well, I said you can think of labor and capital in the same way. So I'm going to redraw this just to kind of keep these separate. I'll do it a little bit smaller here. But if I have investments into labor, same sort of thing exists with that relationship between output or real GDP. As total factor productivity increases, we're going to have something like this. So the final kind of possible response says, as total factor productivity increases, the same level of capital the same real GDP requires more investment in the labor. Well, if I'm thinking about the same amount of real GDP, then actually relative to before, with that total factor productivity increase, what happens to the amount of labor I need to get that same real GDP or that same level of output? It actually decreases. It doesn't increase. And this, intuitively makes sense. If I have an increase in technology or total factor productivity, that means that the same number of workers can produce a higher output, or if I kept output the same, I need fewer workers than before. Okay. Any questions on that one before we keep moving here? All right, so for the sake of time, I want to make sure that we kind of get this entered in correctly. Um, for the second question, so if I'm thinking about that first question, the one that we said is not true was going to be as total factor productivity increases, the same GDP requires more investment in labor, it actually would require less. Okay. Now, for this second question, the correct answer should be 17.6. So just in case we run out of time here, I want to make sure you can kind of get that entered in and submitted if you're watching live or if you watch this after the fact. So we'll kind of work through this one together, but you should have that answer 17.6. So if we run out of time working through this, you can still get it submitted. Okay. So I'm given a production function. I'm given the level of labor and capital, total factor productivity. I then say that there's an increase in capital investments, right? So I'm going to make sure that before I switch off this screen, I've got this written down so I don't forget the exponents here, the values of the exponents here. All right. So we have this kind of production function, and the initial starting amount of capital was 200, total factor productivity was 10, total amount of labor was 200. Also, I want to kind of highlight this Y is really representing kind of my real level of GDP here. So I could make this calculation by plugging all these values in, and I would get approximately 3397.29. So if you're not doing these calculations in Excel or a calculator that kind of stores these out, to hundreds of decimals, I would always round intermediate calculations to do 2 decimals, and you should be okay. Right? You should be fine in terms of the rounding and the margin of errors that are set. So what if instead I had labor was not 200, but it was 300? So before I even go through this calculation, if I increase the amount of labor, what should happen to the amount of real GDP? It should be increasing. Okay. So it's kind of a two-step question. So we could find the new real GDP, and you might be like, oh, it's not, that's fairly easy, right? Because I've got the same total factor productivity. I've got the same level of capital. Now I've just got a labor value of 300, which was given to me in the problem. And I've got kind of my new, if I can read my own writing, I think this is 3,995. Double check. Oops. I didn't have this stored. That's okay. I think these values are right. If not, just gonna do this. I think can't tell from my writing if this was a 5 or an 8. I can enter it into Excel here in a second. So if this was the case, right, I've essentially got what my new GDP was after this labor investment and what my initial starting real GDP was at the old levels of labor. So this question asked me for what is the growth rate in my real GDP? So how do we calculate growth rates, right? So if I want the growth rate in my real GDP, it's similar to what we were doing with inflation, but instead of prices, we're using output or we're using the real GDP. So I would have whatever my new real GDP was, so new GDP minus my old GDP, and then we divide by where GDP started out at. And I'm being a little bit lazy in writing this here. We're always dealing with real GDP, but just to kind of make the shorthand a little bit easier, this is what we would have. Now, if I'm asking you for this, growth rates, I would kind of clarify this in the problem, but we're always looking at growth rates, and we're going to think about here as a percent. So if I wanted the percentage, I need to then multiply this by 100. Okay. So from here, it's really just a matter of plugging our values in, right? So I had my new GDP was 3,995.45. I've got my old GDP was 3,397.29. Now it's just a matter of getting this entered in correctly into my calculator, and I should come up with a value of 17.6%. Okay. And I'm rounding there to the first decimal. If I had this on the exam or in the quiz, I might tell you to round to the first or the second decimal. And then kind of have a margin of error allowance set on that. So in case you're kind of rounding these intermediate values, that won't impact kind of your correctness of that answer. Okay. Any questions on that before I keep moving here? So as a follow-up question in that daily quiz, okay, I say, okay, this isn't a question, but let's think about this because this could be a potential question. Right? So one thing that we notice is we calculated the growth rate in GDP, okay, or in real GDP. What's going to be true if we compare that instead to the growth rate of capital, or in this case, yeah, we did capital. Okay? And the same would be true about labor. Well, capital went from 300, started out at 200, right? So if I make this growth rate calculation, 300 minus 200, which is 100, divided by the initial starting amount of 200, I'd have 0.5. If I want that growth rate in capital as a percent, it would be increasing by 50%. So one thing that we'll notice is anytime we see these percentage changes in labor or capital, these are always going to be greater than the actual growth rate in real GDP. And the reason why is because these powers that we're taking them to are always less than one, right? So whatever that growth rate is in capital and labor, it's always going to be less than the growth rate we see in real GDP or in output, Y. Okay. Any questions on that idea before we keep moving? Okay, so we've got what, 12 minutes left. So are there any questions? I've got some other stuff I can work through, but if there's other questions, I want to make sure I kind of get through those here today. Gave some time earlier, but maybe you've thought of some new ones. Okay. Um, what's another thing that I want to make sure we kind of work through? So let me think what would be helpful. I think this is on some of the practice problems, but I think this would be worth going through. And I talked about this yesterday, but I didn't go through as many examples. So let's say I've got my real GDP or my output, and let's say I've got capital to the 0.4, and now I'm going to introduce human capital, right? And maybe this is to the power of 0.7. Okay. So if I gave you kind of a question where I asked you which of the following is true, or I asked you about the relationship of changes in capital and changes in labor and how that's going to impact real GDP or my output, we said that the same percent increase in both capital and labor, the impact that it would have on my real GDP, if I saw a 10% increase in either capital or in labor, which of the following would increase real GDP, Y output? We can kind of notate this in different ways by more. Well, the same percent increase in either one of these, if something is taken to a larger power, that's going to be a larger value. So anytime we see the exponent on capital be less than the exponent on labor, we know that that same percent increase in both, the one that is going to cause a larger change in real GDP is going to be the one that has a larger exponent. All right. Now, I could compare physical capital to human capital, right? And excuse me, um, I could make the same kind of comparison because when we add in human capital, it's being raised to the same power as labor. So we would still kind of say, okay, if this exponent on labor times human capital is greater than physical capital, we always know that same percentage increase in either labor or in human capital is going to cause a larger change or increase in real GDP than that same percentage change in physical capital. Okay. Now, I could also add something in here that I think I didn't mention in class yesterday. So what if I saw a 10% increase in labor and a 10% increase in human capital? Which would change or increase real GDP by more? Okay. Well, here, if I'm comparing labor to human capital, another way I could write this is actually like this. Right? So when we're comparing physical capital, labor, or human capital, we could compare those exponents. But notice, labor and human capital, at least in our production function that we're using for this class, have the exact same exponent. So which of these is going to cause a larger change in real GDP? The answer would be they would cause the same change in real GDP because they have the same exponent. And that's always going to be true in the models that in the functions that we're using. Okay. We could also be asked different questions like, what if I had, let's say I had a 10% change in capital, and that change was, it was increasing by 10%. If at the same time I had a 10% reduction or change in, let's say, human capital here. Well, we already said the same percentage change is going to cause a larger change in my real GDP if it has a higher exponent. So when I'm looking at kind of my equation up here, and here I'll just rewrite it because we're kind of looking at a separate question. So I've got Y, it's my total factor productivity, K times 0.4, L times H to the 0.7. Well, that 10% increase in capital is going to increase my real GDP, but that 10% decrease in human capital is going to decrease it. However, that same percentage increase and decrease, you might think they offset each other, but they don't, because that same percentage increase is being raised to a lower power over here. So in fact, you know that that reduction in human capital is going to cause a larger change to real GDP, in which case we know real GDP is going to go down. If you didn't know the exponents, you couldn't determine that, right? You don't know. But because we know the exponents, the one that has the higher exponent, if the changes are working in opposite directions, using my hands down here, the one that has a larger exponent is going to be the direction that kind of dictates that total effect. I want to point one more thing out here as well. So any questions on this before we keep moving? So this is maybe less likely to pop up on the quiz, more likely to pop up on the first midterm, but I think it's worth kind of working through. So once again, just to kind of reiterate this point, Y was representing output, which represents real GDP. So if I've got my total factor productivity times K, I think we'll use the same exponents if I can remember them that I was before. Okay. What if we had a similar sort of setup and I had a 10% change and it was an increase in total factor productivity, which we said was represented by or notated by A. Okay. If simultaneously I had a 10%, let's do decrease in labor, right, and I have these happen simultaneously, well, total factor productivity is going up, but labor is going down. I don't, you might think the answer is the change in real GDP is it depends. Now, if I didn't tell you that there was a certain percentage change, that it's not the same, like if I just told you total factor productivity increased, labor or investments in labor decrease, then I couldn't say which of the following is gonna dominate, right? Which of those effects. But if I know that the percentage change is the same, which of these is going to dominate? Well, I actually can make a statement because if I think about this, what is A's, what power is it actually being raised to? Anything raised to the first power is itself, right? And so I could rewrite this as A to the 1, in which case my exponent on A is greater than that exponent on L. So I know that that same percentage change in total factor productivity is going to cause real GDP to go up by a larger amount than that decrease that we're going to see from labor. So you could, I don't think in a lot of the examples we were working through, we're just comparing capital, physical capital to labor, or physical capital to human capital. You could also kind of look at these simultaneous changes in total factor productivity and compare those same percentage changes to capital and labor as well. Now, I know that we worked through this with a problem where we said like the same 10% increase is larger from total factor productivity, but I didn't really go through the kind of maybe a different way of thinking about it. And so this would be another potential kind of fair game question. So one other thing that I'll add in here is let's say I work through a similar example. So I know we've only got a couple minutes, but I think this is worth it if we're thinking about both the quiz and the exam. So let's say I've got that same equation and let's say I kind of even simplify this. Let's say I simply do uh, just labor, not human capital. Uh, so if I told you in a problem that the depreciation in physical capital was greater than the investments I'm making, and then said, what's given this function, what's going to happen to real GDP? Well, we know that the level of capital is equal to whatever the starting amount of capital was, plus the investments we made, minus the depreciation of our old physical capital, right? Buildings getting older and no longer being able to be used. So what would this do? Well, if depreciation is greater than my investments, I know that this difference, right, is going to be a negative value or less than zero. That's going to cause my physical capital to decrease, in which case I know that that's going to cause my real GDP to go down. And we could do a similar thing with labor. I know we worked through a problem earlier where labor was equal to the initial starting labor plus our inflows minus our outflows. So if I told you something about the relative size of unemployment and employment, you could determine what's happening to labor and then what's happening to real GDP. So kind of combining those two concepts into one question. All right, so that kind of wraps us up time-wise here. Any questions that you have, I'll kind of end the recording here. Try to work through the materials, practice problems, quiz, and if you have any questions tomorrow, once again, I'll kind of go through the ones that you guys start out with. We didn't really do anything with Module 3 today, so I'll probably come to class tomorrow with some some questions that vary from those materials over Module 3, just so we kind of make sure we do some review together of that. But I'll start with all of your questions first, okay? So nothing really due tomorrow. You've got that Canvas discussion. You've got the second quiz that are both due at the end of the day on Wednesday, so tomorrow, and then we'll have that first midterm on Thursday. So I'll end the recording here.